Okay, looking at question 5 for Carbonyl compounds tutorial. We have a chemical test question from 2023 A levels. So first of all, they give you some context. A, B, and C are both all straight chain molecules with molecular formula C5H8O2. So C5H8O2, they say that it's a straight chain, so you expect 5 carbons to be in a straight chain. More importantly, they say that no oxygen atoms are present in the carbon backbone. Right, so you basically have 5 carbons like this, and then you do chemical tests on A, B, and C, which is then summarized in the table below. We are supposed to deduce the structure of A, B, and C then. So before we start, alright, it's important for us to know what each chemical test is looking out for. So with sodium, quick recap, your alcohols and phenols can undergo redox acid metal displacement. So it's to test for your alcohols, phenols, and carboxylic acid. Alright, so your Na, right, can test for these 3 functional groups. Alright, all of which will give you effervescence of H2 gas. Moving on, for aldehydes, Tollens reagent, alright, to test for aldehydes is something that we went through quite a number of times in the earlier question. So to test for all aldehydes in oxidation reaction, the positive test will be a silver mirror. Okay, and then moving on to alkaline aqueous iodine is to test for your CH3, CO, your ketones, alright, or your alcohols. Alright, so alcohols with this, aldehydes and ketones with this. Alright, okay, last but not least, with bromine, bromine undergoes electrophilic addition reaction, so you can test for your alkenes. You can also test for your phenol and phenylamine. Alright, so alkenes and phenol. Alright, so in this case, if we take a look at this context, A, B, and C, alright, so from there, we will be able to decide what is the functional group present in A. So if we take a look at A has no reaction with sodium, so therefore no alcohol, no phenol. Alright, so no alcohol, no phenol. Alright, it also has no reactions with bromine aqueous, bromine liquid, so it does not contain any alkene. And last but not least, it also has no reactions with alkaline iodine, so it does not contain your methyl ketone. But we know that since it forms a silver mirror with Tollens reagent, it must contain an aldehyde functional group. Okay, so based on this, the question wants us to think of the structure of A, and given that we earlier said that A, B, and C all have a straight chain, the only possible structure for aldehyde for A will be this, right? So you have 1, 2, 3, 4, 5 carbons, you have an aldehyde, and then we just have to add in all the H's. 1, 2, 3, 4, 5, 6, 7, 8. So if you take a look at this, alright, you realize that you actually don't match the molecular formula. Alright, there's 2O, so as a result, since there's only aldehyde functional group, what I can propose is then the last carbon will also be an aldehyde. Now, if you now count the molecular formula, 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, C5 is done. We have our 2 aldehyde functional groups. Okay, so aldehyde group done. We now count the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. H8 done. And then, of course, the last 2 oxygen atoms, right? 1, 2. So 2O done. So therefore, this is likely the structure of your A, where you have 2 aldehyde functional groups. So the aldehyde functional groups must be at the terminal end in order for it to be a aldehyde. Okay, moving on. The question asks us to write an equation for which occurs when A reacts completely with an excess of acidified dichromate. So acidified dichromate is your oxidation reaction. Alright, so what happens is that your aldehyde, in this case, RCHO, upon oxidation, will become RCOOH. The question wants a equation, so we need to balance the correct number of oxygen. So essentially, you can see that every time you do this, you just have basically inserting a O in between the CH bond. right? You're adding an additional O in between the CH bond. So in this case, you have two aldehydes, you basically need to balance it with two oxygen to form two COOH. And so far, so oxidation of our two aldehyde groups to carboxylic acid. Okay, moving on. Now we need to phantom up the structure of B. So let's take a look at the information for B then. For B, there's no reactions with sodium. Again, with silver mirror, which indicates that it must be an aldehyde. Now we have a yellow precipitate for alkaline iodine, but there's no alkene again. Alright, so we can write down quickly what does B contain. B contains aldehyde. Okay, because of the tolerance, it contains CH3, C double bond O. Right, because of your positive iodoform has pure yellow PPT. It can also contain, of course, CH3, CH, OH group. That's your same thing as iodoform. And then we have no alkene. And then why? Because this PR2 doesn't decolorize. And then no alcohol. Okay, no alcohol because the sodium test, there's no reaction. So as a result, because there's no alcohol, right, this group therefore can be eliminated. So as a result, if you take a look at the structure of B, B must contain an aldehyde and a methyl ketone. Alright, so in this case, if you look at it, C5H8O2 again, earlier we see it contains aldehyde group, silver mirror. It also contains your methyl ketone group, but does not contain alcohol nor alkene. So as a result, because the question earlier said A, B, and C all has a straight chain carbon, first of all, we draw our aldehyde group. So we have double bond O and the H. That's an aldehyde group. So we set up aldehyde group first. And then it must have this CH3CO group, right? So we put a double bond O here. We change this to a CH3. And now we have our CH3CO group. Okay? And then remaining H's, we just add in 1, 2, 3, 4. So we check the functional group now. Aldehyde, methyl ketone, both have. Alright, so this one, take. Do we have 5 carbons? Let's count. 1, 2, 3, 4, 5. Yes, done. Do we have 2 oxygen? Yes, done. Right, 1, 2. Do we have 8 hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. Okay? Hydrogen also done. And therefore, this will be the likely structure of B. Okay? So, methyl ketone, and then your aldehyde. Okay? So now, moving on, they say that D state the formula of the yellow precipitate. The yellow precipitate will be your CH3. This is quite straightforward. It's basic recall. Okay? Now, last but not least, we now focus our attention on C. The molecules of C do not show stereoisomerism. So stereoisomerism, recall, what does it contain? What does it constitute? It contains both cis trans as well as enantiomerism. Right, so cis trans isomerism and enantiomerism, what we can therefore conclude is that C does not exhibit cis trans isomerism and do not contain chiral carbon. So what's the structure of C then? So let's take a look at C again. C, first of all, positive sodium test. So possibly alcohol, definitely no aldehyde. Alright, there's no CH3CO group, but it has an alkene functional group, brown to colors. Your bromine actually decolorizes. So if we take a look at structure of C then, C again has C5H8O2, contains alkene. Alright. And contains either alcohol, phenol, and carboxylic acid, unlikely to be phenol and carboxylic acid in this case. Alright, so, unlikely to be phenol in this case because there's only 5 carbons. Alright, and in this case, C does not contain aldehyde functional group, does not contain methyl ketone. So again, we have to rely on the clue given by the question. The question says that C carbon chains, the 5 carbons are in a straight chain. Right, so it must contain an alkene. Must contain alkene and does not exhibit cis trans isomerism. This must indicate that this must be a terminal alkene. So let's try to draw a terminal alkene first. So we have a H and a H. Right, so once you have a terminal alkene, this makes it a lot easier for us to handle. And then now we need to draw in the missing H's. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So in this case, we realize that we have drawn in 7 H's already. Alright, count the number of H's, we have drawn in 7 already. We're only left with 1 H. We're left with 1 H and 2 oxygen atoms. So therefore, the only possible functional group will be CO, O, H. And so far, and this is how I get my first answer. Alright. Alkene with a carboxylic acid. Okay. So carboxylic acid can also react with sodium. Alright, to give hydrogen gas. This will be covered in carboxylic acid and derivatives. Alright, so carboxylic acid can also react with sodium to give H2 gas. Another possibility is that now, instead of thinking of carboxylic acid, I can actually make it a ketone, a double bond O, and an OH, a primary alcohol. So this is another possible structure I have. I get a primary alcohol, but instead of putting a double bond O together with on the same carbon, what you can see literally is that I shift the double bond O to over here, right? So I shift the position. Now, instead of getting a carboxylic acid, now I have a primary alcohol and a ketone, but I still have a terminal alkene. So that's also another possibility. Okay. Last but not least, I have my primary alcohol, and now in this case, I shift my ketone another position down to be further away from the primary alcohol. So you can see now there are 2 carbons in between the primary alcohol and the ketone. Earlier was 1 carbon. Earlier they was together as a carboxylic acid functional group. And that's how I can get any of these 3 structures. Again, what are the functional groups present? Alkene, to be exact. And more importantly, because it cannot exhibit cis trans, we therefore propose a terminal alkene. Alright. Next, we must have either alcohol or a carboxylic acid. So alcohol or carboxylic acid. Okay. Now, then in this case, the ketone part is really largely to balance the number of hydrogen atoms. Alright. So that's why we have to propose a ketone functional group to decrease the number of hydrogens required. Okay, and with that, we are done. So over here, some of you may ask, how do I know that I must have a double bond O? Now, this is one important portion that you guys can take note of for those of you who are able to understand this. Every time we have a double bond, right, be it CC double bond or CO double bond, every time we have a double bond or multiple bonds, we have what we call a concept of degree of unsaturation. Okay, so this degree of unsaturation basically will therefore decrease the number of H atoms by 2. Okay, so you can see with an alkene, right, we therefore has 2 less hydrogen atom required for the entire molecule to be fully filled. Same thing for C double bond O. And over here, that's why when I went through this portion here, after filling in the alkene, after drawing on the H's, then I realized that, oh, the possible structure that I can have with only 2 O's and 1 H remaining, after using up 7 hydrogens, I can only have a COOH. And once I recognize that, oh, I know that it must be a C double bond O in order for us to keep to only 8 hydrogen. Okay, so then the subsequent portions will get the different structures. Other structures will be to shift your double bond O position, alright, further and further away from a primary alcohol. This is how I can get the possible structures of C. Okay, with that, we are done with question 5.